Hello guys, today we want to do some math for fun again, and we are going to be looking at calculus today. Calculus, this is going to be our first calculus on this channel, and I promise you it's going to be awesome. Now the question is the integral of the square root of 1 minus x squared dx. Yes, I found this question somewhere. Now we can solve it two ways, either with the trig substitution or with the integral by parts. But only few know that we can solve it with integral by parts, and you are going to see I'm going to get it done here now. Now I would like you to tell me the one you prefer from out of the two methods. Is it either the integral by part or the trig sub? You tell me the one you prefer. Now let's go into the main work and see how fun it is. Let's see. Okay, I'm going to start with the trig substitution, and by doing so I will say let x equal sine of theta. If x equals sine of theta, then theta will become arc sine of x, like this. So anyway, I see x, and I'm going to put this. Then the integral will become the square root of 1 minus sine squared theta dx, like that, isn't it? Okay, if that should be the case, let's find how we're going to substitute for the x. So let's differentiate this. If I differentiate this, I will have that the x equal what? Cos of theta d theta. Hence, I can substitute for this. So I will have that this is going to be the integral of the square root of 1 minus sine squared theta. Instead of the x now, I will have what? Cos theta d theta, like this. Are we together? If this is what we have, the square root of 1 minus sine squared theta is the same thing as saying cos theta. If you can recall that, sine squared theta plus cos squared theta equal what? 1. So you see that cos theta is the square root of 1 minus sine squared theta, like this. So, and that is what we have here now. So this will become the integral of cos squared theta d theta. Cos theta times cos theta will give us cos squared theta. Are we together? Now, if this should be the case, it will be very difficult for us to integrate what? Cos squared theta. Now, let us express what? Cos squared theta in another form. Are we together? Now, before we go that, I would like you to quickly recall from multiple angle formulae that cos squared theta is the same thing as saying what? Cos 2 theta plus 1 all over 2. You can try this. You can try this on your own. If you expand cos 2 theta, then make cos squared theta the subject of the formula, you end up having this. So if that should be the case, I will replace what? Cos squared theta with this. Hence, I'm going to have that. I will have this to be the integral of cos 2 theta plus 1 divided by 2 d theta, like this. I believe we are making sense. Now 1 over 2 is a constant. Let's take it out of the integral, like this. So I have 1 over 2 integral of cos 2 theta plus 1 d theta, like this. So this is the same thing as saying 1 over 2 into integral of cos 2 theta d theta plus the integral of d theta, like this. So the 1 over 2 will affect everything in the bracket. So we are still on track. Hence, this one will give us 1 over 2 into 1 over 2. This will be sine 2 theta, like this. Then plus, this will become what? Theta, like this. Don't let us add c now, because we are still in the theta word, and we need to take it back to what? X word, because that is what we are given. Okay, if that should be the case, we recall again from the multiple angle formulae that sine of 2 theta is the same thing as saying 2 sine theta cos theta. So let's take that to this place. So we have 1 over 2 into 1 over 2 times 2 sine theta cos theta, then plus theta, like this. So these 2 and these 2 can cancel, and I'll be having what? 1 over 2 sine theta cos theta plus 1 over 2 theta, like that. Okay, if that is what I have, I think we are progressing. So let me clean this like this. So we have that the integral of the square root of 1 minus x squared dx equal 1 over 2. Sine of theta is the same thing as what? X, like this. So I'll put x here. Then cos theta, if you remember, is the same thing as saying the square root. You know, cos theta is the same thing as saying the square root of 1 minus what? Sine squared theta. And sine squared theta is the same thing as saying what? X squared. Hence, cos theta, I will replace it with the square root of 1 minus x squared, like this. Okay? Plus 1 over 2 theta. Our theta is arc sine of x. So this is arc sine of x plus c. So our result for integral of 1 minus x squared dx equal 1 over 2 into what? X root 1 minus x squared plus arc sine of x then plus c. And this is going to be our result when we use the trigonometry substitution. Mind you, if you differentiate this function, you will have this back. You can try it at your leisure time. Okay, let's use the integral by parts if we are going to end up with the same result, which I'm sure we have. Let's see. Okay, you are going to tell me the one that is more fun. Remember, the one that is more tricky and more taxing is the one that is what? More fun. Let's see. Now, I would like us to recall that u dv is equals to uv minus integral of v du. Mind you, the one that you want to differentiate is what you are going to let to be u, and the one to integrate is going to be what? Dv. Remember that. Okay, let's go. I cannot let my dv to be what? The square root of 1 minus x squared, because that's what we want to integrate. Hence, I'll say let my u equal the square root of 1 minus x squared, like this, and my dv will equal what? Dx. Isn't it? You know, if I multiply these two together, I will have this back, like that. So, what will be our du? Our du is going to be, okay, this is going to be 2 root 1 minus x squared. If I differentiate this, and the top is going to be minus 2x, like this. So, dx. And if I integrate this, I will have what? My v to equal to x, like that. Okay, if that should be the case, this and this should take care of each other. Then I have that my du equal what? Negative x divided by the square root of 1 minus x squared dx, like this. And v equal what? X. So we can substitute this into the formula now. So we have that integral of our u, which is this, and our dv is this. So we have the question back, and this is the x equal our uv. Our u is this, and this is our what? V. So we have what? X root 1 minus x squared, then minus the integral of du, v du. So that will be x times x. That will be negative x squared divided by the square root of 1 minus x squared dx. Okay? Yes. This is where the fun lies. How can we integrate this? This is crazy. If you dare to use u substitution, we are going to have one x left here. Automatically, u sub cannot work. But before we look at what to do here, because that is where the fun lies, seriously. But before we look into that, let's quickly look at this. If I have, let's take for instance that I have 2 divided by the square root of 2. Do you know that the result is still the same thing as root 2? Do you agree with me? Yes. If I cross multiply now, 2 will equals to 2, because root 2 times root 2 will give me 2. So, and also if I say, let me say I say x all over root x, my result will become what? Root x. Provided that what is here is what is under the root, the result will become what? The root itself. Are we together? That is another thing that we need to know. So let's quickly think on how we can rewrite this equation to suit what? This method. So I will first of all say let I equal the integral of the square root of 1 minus x squared dx. Okay? If this should be the case, I have that my I is equal to x, the root of what? 1 minus x squared, Don't worry, minus times minus is supposed to be plus, but don't let us do that now to make life easy for us. So we are going to have what? Negative integral of 1 minus x squared divided by the square root of 1 minus x squared. Remember, this is this, but this equation now will be wrong because we've tampered with what is here. In order to take care of what is here so that we're going to be mathematically correct, let us subtract 1 again. So we have this, the x, like this. Okay, we have not done anything wrong because 1 minus 1 is 0. We still have what? Negative x squared back. So no qualms, isn't it? Yes, that's mathematics for you. So we can now say I equal what? X root 1 minus x squared minus the integral of 1 minus x squared all over the square root of 1 minus x squared dx. Then we have what? Minus integral of the x all over the square root of 1 minus x squared, like that. Yes, that is what we have. Okay, so you will now agree with me now that this, if I clean this like this, so let's just look at something like that. You now agree with me that I is equal to x root 1 minus x squared, then minus, this is like what I just explained now, that if this is x and this is root x, the result will be root x. So this is in terms the same thing as saying the square root of 1 minus x squared dx, like this. Then plus, if I integrate, this is going to be minus. No, this minus is to affect everything in this bracket. So let's assume that I've distributed the minus. So this will become plus. Then this is going to be integral of the x all over the square root of 1 minus what? X squared. Okay, we're getting to the final answer. So this is going to be what? I equal what? X root 1 minus x squared. Then minus, if you look at this, this is like the integral that we start with. That is, I is that. So okay, so this is minus I, like that. Then plus the integral of 1 all over the square root of 1 minus x squared is the same thing as saying what? The arc sine of x, like that. Yes. Okay, if I transfer this one to the other side, I will then have what? I plus I to equal what? This 1 minus x squared. Then I have plus the arc sine of x, like that. Yes. This plus this will give us what? 2i. Then this 2i equal what? Then 1 minus x squared plus the arc sine of x, like this. Hence, I can then say, okay, let me clean this side like this and see what we are going to end up with. Okay, I will now say divide both side by 2. So I have my I to equal what? 1 over 2 into x root 1 minus x squared plus the arc sine of x, then plus c, like that. Yes. I is what? The integral of the square root of 1 minus x squared dx equal 1 over 2 into x root 1 minus x squared plus the arc sine of x, then plus c. Here is our result, like this. I love this method very well compared to the trig sum because this is more taxi and more fun. I don't know yours. Let me know the one you love most in the comment section. Don't forget to subscribe to this channel. Thank you for watching. Have a nice day.